you have to make sure that when you write down the dimensions of the matrix, that is how many rows and columns it has, you have to make sure that the inside two are the same. So, what are the dimensions of this matrix right here?
2 by 2.
This is a 2 by 2. 2 rows, 2 columns. What are the dimensions of this guy?
2 by 3.
3 by 3. 3 rows, 3 columns. Now, can these be multiplied?
No.
No, because the rule is those two numbers have to match. So this is, I can't do it. It's a not possible problem. Cannot do it. All right, so let's go right on to the next one. Here's the next one. What are the dimensions of this matrix? 2 by 2. And what are the dimensions of this one? 2 by 3. Can these two be multiplied? Yes. And the new matrix, the answer matrix, will be another 2 by 3. Remember, these have to match, and this gives you the dimensions of the answer. Right? So now I have to start figuring out what these numbers are in here. So I'm going to look right here at this spot. This spot, I'm going to figure out what this number is. This spot is in the first row, first column. So I am going to multiply the numbers in my first row, which are 1 and 1, by the numbers in my first column, which are 1 and -3. Okay, remember that? So I multiply each pair and add them up. So what is the number that's going to go in that first spot? -2. All right, then I pick another spot. I always just go this way just to stay organized, but it really doesn't matter. You go where you want. If I'm going to choose to go here, if I want to find this, what position is this? It's still the first row, but now it's the second column. So I'm still in the first row, so I still have my 1 and 1, but now I have my second column, which is 2 and 1. So that number is a
3.
3. Okay, now what?
First row.
First row, still in the first row, so still 1 and 1, first row, but now I'm in the third column, so it's going to be 3 and 0, so that's another 3. All right, now what's going to happen? Now I'm going to have to go to the second row, so now I got to go here. So I'm going to be using a 3 and a -2. That's my second row. And for this spot, I'll pair it up with 1 -3. First column, second row, first column. So what is that?
1.
Oh no. I don't think that's 1, is it 9? I think that's 9. That's 3 plus 6. And then, what's this? Second row, so still 3 and -2, but now it's the second column, 2 and 1. So what's that? Multiply each pair and add them up. 4. And finally, the last spot here is in row 2, column 3. So 3 and -2 again, and then 3 and 0. And we're done. Okay, that was letter D. I'm going to have to erase it to do the next one. Actually, before I write the next one down, let's see if we can do it. Can we do G times E? What are the dimensions of G? 2 by 3. Rows, columns. What are the dimensions of E?
3 by 3.
Uh-oh, we can do it, can't we?
Yep.
Yep, so I'm gonna have to write it all out. Okay, so here we go. We're multiplying G times E. Okay, so G Okay, so we decided we can multiply. And how big will our answer be then?
2 by 3.
2 by 3. So my answer is gonna have 2 rows and 3 columns. It'll look like that, so I'm gonna be finding those 6 numbers. Okay? Now, how am I gonna do that? Well, what is this? This guy right here is row 1, column 1. So row 1, column 1. So 1, 2, 3, there's row 1. And then pair it up with 1, 1, negative 1. That is column 1. Okay, so more numbers here, but you do the same thing, pair them up, and then see what that adds up to. 0, we got 0. Okay, so that's 1 and 2 and negative 3. All right, next, still row 1, so still 1, 2, 3. But now I'm in column 2, from here. What does that add up to?
6.
Negative 1 and 4 is 3, and 3 plus 3 is 6, yeah. All right, see if you can fill in this one. You can get that one on your own. What is that? That is row 1, column 3. So, see if you can figure out what row 1 and column 3 is gonna add up to when you pair them up, multiply and add. What'd you get? Not 17.
It's 9. It's 19.
It's not 19. It's
18.
18. It's 18. Yeah. Remember, when you times by 0, you get 0. So that is 18. All right, now we're ready for this guy. So now we're moving on to row 2. So negative 3, 1, 0. And here, we're pairing him with column 1, which is 1, 1, negative 1. Okay, so that looks like, is that negative 2? All right, go ahead and finish it. I'll finish it on my paper, you finish it on yours, and we'll compare answers. looking at? Five, good, that's what I got. I got 3 for this last one too. Anybody not get that, those two numbers, and can't figure out what happened?
I got one, I just can't figure out.
Which one?
The
Instead
middle
of
one.
what? Instead of 5, you got
Yeah.
1. So this is row 2. Column 2.
Oh, I times it by 2. Okay.
So that's 3 plus 2.
Yeah.
Okay, one more multiplication, and we're moving on to something else. Can we do F times G?
Yeah.
Is F times G going to be possible? Because sometimes this stuff isn't possible. What do you think? Possible? What are your dimensions here? 2 rows, 2 columns. What are your dimensions here? 2 rows, 3 columns. I think you can do it. And the answer is gonna be one that looks just like this. It's gonna be another 2 by 3.
So for these ones, it's important what you're multiplying first.
Absolutely. Okay, here we go. Do it. Let's see if you can fill them all in on your own. We'll compare answers. All right, who's got some numbers for us? Anybody have a top row?
I got
Negative 16, 3, negative 3. Let me check what I got. That's what I got. Anybody not get one of those? If you didn't, it's probably because you made an arithmetic mistake. Okay, how about who's got a bottom row? 369. Let me see. Yep, that's what I got. 369. Daryl, you on board? You rocking your matrices? Awesome. Okay. All right, we're done practicing that. Of course, you can always go back and redo them, and there's one in your homework to practice too. Number 3. Now we're doing something different. Does anybody see anything different about the way that problem is written? It looks like absolute value. It doesn't have these brackets. That it really isn't absolute value, but the notation is the same. This is what we call a determinant. A determinant. Determinants are denoted with the absolute value signs. okay, these straight bars. And every time you see one, you know the answer is just going to be a single number. So we're gonna do a computation here, and the answer is gonna be just a number like 6 or something like that. Up here, when we were multiplying matrices, our answer was another matrix. Here, one number, and here's how you find the number. It's really simple. Take 1 times 4, 1 times 4, take 3 times 2, so 1 times 4, 3 times 2, and subtract. Subtract. So it's this minus this. This minus this. So the answer to this problem is simply -2. Now we're going to do things with determinants in a little bit, but first we have to figure out how to evaluate them. Okay, so what about B? Same exact sort of problem. These bars tell me I'm a determinant and I need to be evaluated. So I start right here, I multiply. What do I get when I multiply this way? 14. And what do I get when I multiply this way? -3. And then I always subtract. So it's 14 minus -3, and that's 17. Okay, would you do C? C is exactly the same thing. You're evaluating the determinant. Watch your arithmetic. What did you get?
11.
Okay, I hear about 6 different answers. This is not good. All right, watch your arithmetic. I would suggest maybe you even write it down. So what do you get when you multiply here? -3. What do you get when you multiply here?
-8
What do you get here?
minus
What's 2 times 4?
8.
8. And then we subtract. What is -3 plus -8? -11. The answer is -11. Okay? Alright, so again, we multiply these, and we subtract those 2 numbers. Okay? Fun fact. I mean, it's not fun. It's not fun to me. It traumatized me. Obviously, I still remember it. When I learned how to do this, my teacher gave us a quiz. In my life, I failed 2 quizzes, and one of them was this one. Because
One of mine is the last.
I
failed 2 quizzes in
didn't
your
do
life.
the operations correctly. And the other one I failed was in 7th grade. My teacher, Mrs. Searfoss,
In any class?
gave me, we were supposed to have read the Celebrated Jumping Frog of Calaveras County. I don't know if any of you have read that or not, Mark Twain's story. Anyway, we were supposed to have read it, and guess what? I didn't. And she gave us a quiz, and I failed it, and I'll never forget it as long as I live. She called me up to her desk, and all she said to me was, "Lisa, I'm very disappointed."
From there on
I
out.
just-
From there on out. That was so very really supportive.
Because I was kind of a goody two-shoes.
That's a great story.
That was the last time.
They don't.
No.
I bet A on every quiz possible. This one.
Now, we practice the 2x2s. Those 3 that we just did were 2x2 matrices, right? Now we have a 3x3. It turns out that you can only evaluate determinants these bar things, if the matrix is square. We talked about what that meant last time. Square means 2 by 2, 3 by 3, 4 by 4. You can do determinants for all of those. This is a 3 by 3. There are a couple of different ways to evaluate. I'm gonna show you what I think is the easiest way. Here's what I want you to do. Take the first column and write it down right out here. Then take the second column and write it down right out here. So I have simply taken my first two columns and I've rewritten them in order, including negatives and everything else, right over here. With me? Now I'm going to start right up here where I started before, and I am going to multiply those numbers together. So 1 times -1 times 1 is -1. Then I'm going to multiply these three numbers together. What is it? 6. And finally, I'm going to multiply these three numbers together. What is it? 0. Now, find the grand total of all that. So the grand total of -1, 6, and 0 is 5. Now we're half done, because now we're going to turn around and go the other way. Remember when you did your 2 by 2, you multiplied these two together, and you multiplied these two together? Well, I'm doing that, but it's on a bigger scale. These are my downs, I just did these, okay? Now I'm going to do these. So I'm going to multiply these three, what do I get? 0. And then I'm going to multiply these three, what do I get? -6. And then I'm going to multiply these three, what do I get? 0. So total those up, and all of that ends up being -6. So think back to the 2 by 2s. You do these, you multiply these, and you multiply these, and then what do you do with those two numbers? Subtract. So I've got these, all of these are 5, all of these are -6. So now I'm going to subtract those two numbers, and the determinant is 11. So it's the same exact idea. Multiply, multiply, subtract. Except you've got more of it because the determinant is bigger. Okay, let's try E. Same thing. What's the first thing we're going to do? We're going to write our columns, just the first two. And make sure you're doing it in order. So this one, and then this one. Okay, now we're going to multiply. Always start here at the beginning. This is the beginning. This is the first number you wrote right here. That's where we start. So we're going to multiply. What do we get?
36.
What? 36. And then we're going to multiply carefully. What do we get? Guys, there's a 0 in there.
0.
You're always going to get 0 if you're multiplying by 0. And then what do you get here? 1. So then we total that up and we have 37. Then we go do the same thing, other direction. So now we're going to multiply these and we get -8. And then we'll multiply these and we get 0. And then we'll multiply these and we get 6. So that adds up to, the -8, the 0, and the 6 adds up to -2. And what do you do with those two numbers? Subtract. So it's 37 minus -2, which makes 39.
you have to do it in the order that you like. That you go
Yes. All right, one more. Try this one on your own. It's exactly the same thing. How do we feel about -16? Jack feels good about that? Okay? Okay? So we're learning lots of new operations. They're all easy, but you have to stay organized for sure. And remember the process. All right, we have one more to learn. And that is, we're gonna learn how to find the inverse of a matrix. So, this is just some random matrix, and we're going to find its inverse. That is the notation for inverse. We've done that before, we've used that notation. Before we were doing it with functions, so we said f inverse, that was the inverse of the function. Well, this is gonna be the inverse of the matrix. Inverses are necessary because in matrix land, there is no division. So if you want to divide in matrix land, you have to multiply by the inverse. You know how if you take 6 divided by 2, that's the same as 6 times 1/2? Well, this is the way you have to do it in matrix land. You have to find the inverse, and it's not 1/, although there's some 1/, in it, but it's not that easy. Anyway, here's how you find it. It's a 2-step process. So step 1 is find the determinant. Okay, so we just practice that. Who remembers? This is a little 2x2. How do we find the determinant? This is the quiz I failed. We go 1 times 5. We do -1 times 2. And then what do we do with those two numbers? Subtract them. So 5 minus -2, you should have gotten 7. So your determinant is 7. Step 1, find the determinant. Okay? Step 2, you're gonna build a new matrix. And that new matrix has a name, it's called the adjoint, but you don't need to worry about that. You just need to know how to build the matrix. Here is how you do it. Listen carefully. These two numbers right here, where my fingers are, you're gonna flip-flop them. So you're gonna take the 1 and the 5, and they're just gonna switch. So now it's gonna be 5 and 1. Those two get switched. Okay? Now the other two numbers, which are these guys right here, if they're negative, you make them positive. If they're positive, you make them negative. So in other words, you change their signs. So these two, you're making a brand new matrix, taking these two numbers and flip-flopping them. And then these guys get their signs changed. So a negative becomes a positive becomes a negative, but they stay right where they're at. Your inverse will be that matrix with each number divided by 7. Now, why am I dividing by 7? Because that was the determinant. So whatever the determinant is, once you build your new matrix by flip-flopping and changing signs, you divide it all by the determinant. Now, in our problem, we couldn't reduce, but if, let's say we divided by 6, then that fraction would reduce, and you are expected to reduce it. But we're done, nothing changes in that one. Okay? All right, let's try the next one. We'll do this together. Now, have you try one on your own? Let's go through this process again. So what is the first thing I need to do if I'm finding the inverse of this matrix? Find the determinant, okay? So what's the determinant? 4. It'll be 1 times 4 and 0 times -3 and subtract those. So isn't that 4 minus 0, isn't that just 4? Now hang on to that number. Now you're gonna build your new matrix. And how do we build that? These two get flipped. So I'm gonna have 4 and 1. Now that's a 0, so it just, that doesn't, can't change that. And that becomes a +3. And then I take that new matrix, and each of them gets divided by 4. So in this case, I can clean it up. That would be 1 and 3/4, and 0 and 1/4. And that's the inverse. Okay? All right, try that last one there. Try C on your own. Let's see what you come up with. Bless you. Josh is agreeing with me. Anybody have a question about that? Did you get 10 for your determinant? Because it's 6 minus -4. Did you reduce your fractions? All right, well, lucky for you, there's one more. One more. Okay, did you do that last one for me? Problem D. The determinant is 0. Now, stop and think a minute. What do we do with the determinant? Okay, wait.
What's,
Can we divide by 0? So this matrix has no inverse. It's called non-invertible. No inverse. So in matrix land, that is a bad thing, but it happens, and it just means we're kind of dead-ended.
Okay, so once you see that 0, that means.
If the determinant is 0, you cannot build an inverse. Right? If the determinant is 0, you cannot build an inverse. Okay, so we're gonna pause there, because we're gonna have another quiz. We won't get through the whole practice today, but I wanna get started on it. And you will start needing your calculators. You haven't needed them.
is this what time of year?
No, it'll be the time after. No, we're not gonna get through this. We won't get through this practice quiz today.
Is it just these two things?
So we'll continue the practice quiz next time and have a quiz the time after that. So what will happen is, we'll finish this practice quiz on the e-learning day, right? Because I don't see you tomorrow. And then your quiz will be the next day after that. So you'll definitely want to watch the e-learning. Some of you aren't very good about that, but you will definitely want to do that. Okay. So, here we go, practice quiz. The very first thing is what you did on your quiz that you took today. Now, what do you notice though? It just says solve.
So you can choose.
So you get to do it however you want. So if you are a substitution person, use substitution. I am not, I'm an eliminator, so I love to eliminate, so I'm gonna eliminate. But this problem would be easy either way, because you got a y sitting there all by itself, so you can substitute if you wanted. So go ahead and do your thing, whatever that is, substitution or elimination. We should get the same answer regardless. I will do my thing. And we will see if we get the same answer. Here's what I got, but it could be, I could have made a mistake somewhere. What you got? So remember that we write our answer as an ordered pair and make sure you have the numbers in the right order. So X, Y. So my X was 3, my Y was -1 when I plugged it back in. Okay, you good with that? All right, next problem. Problem 2A. What does this mean? This is from last time. What am I looking for here? Row 2, column 1 in matrix B. So in matrix B, row 2, column 1 is what number? 2. So the answer to 2A is 2. Because in matrix A, or excuse me, B, matrix B, the number that is in second row, first column is 2. What are the dimensions of matrix A? 2 by 3. Guys, rows by columns. 2 of these, 3 of these. A plus C. This is problem C. A plus C. Can't do it. Why can't we do it? No, it doesn't have to be square. The dimensions have to be the same. How big is matrix A? 2 by 3. How big is matrix C? They don't add. The rule for add is the dimensions must match. They can be anything, but they have to be the same. All right, D, can I multiply A times B? All right, how do I know if I can multiply them? Well, what are the dimensions of A? 2 by 3. What are the dimensions of whatever this is? B. This is 3 by 3. I am multiplying. So the rule for multiply is those match. And they do. So my answer will be another 2 by 3. So we got 2 minutes. Let's see if we can get this done. This right here, row 1, column 1, right here. So negative 1, 1, 5. That's row 1. And 1, 2, 3. That's column 1. And that adds up to 16, did I add right? Row 1, column 2, if I'm going here. What is that, negative 6? And finally, row 1, column 3. I think that's 27. Okay, on the bottom, you should have a 9, a 1, and a 7, I think. Alrighty. Okay, next time I see you, it'll be learning. Woo-hoo! Then we'll have a quiz the next day after that, okay?